When solving literal equations, it's important to first identify which variable you're solving for. In the problem number 1, they're asking us to solve for y. As I look at the equal sign, y is on the left-hand side. That means that y will always stay on the left-hand side. My final product here will have y equals, and I will have an expression in terms of x on the right-hand side. Everything that's on the same side of the equal sign as y needs to be moved. So in this case, I need to move the 4x and the 2. You're still following your inverse order of operations. So that means you're going to add or subtract before you multiply or divide. It's just that in this case, you're not adding or subtracting only numbers. You might have variables in there as well. For example, I have to move this 4x before I can move the 2. To move the 4x, because it's positive, I subtract it on both sides of my equal sign. 4x minus 4x here goes away. That leaves me with positive 2y equals, these are not like terms, 8 and negative 4x. Because they're not like terms, I'll take my top term, 8, and then my bottom term, negative 4x. Since it's negative, I make it subtraction. Make sure that you include your sign. Once we're at this stage, we see that y is still not by itself like my goal was. If I look at just this side, so forget what's on the right-hand side, we don't even need to know about it yet. I know I have to move the 2. Because it's 2 times y, to move the 2, I'll divide by 2. That way the y stays. I never moved it. My 2's will cancel. Now that we've divided on the left, I have to divide on the right as well. That's when you have to check to see, is it all multiplication here? If so, you just do one division. If it's not, like in this case, and you have addition or subtraction, then you have to divide every term by 2. In this case, there's 2 terms. A term is separated by an addition or subtraction sign. So I have to divide the 8 by 2 and the 4x by 2. This left my y alone on the left. I bring my equal sign down. When I have these fractions, I want to simplify them. 8 over 2 simplifies to 4. It's a subtraction sign, so I'm going to subtract. 4 over 2 is 2x. What you want to understand is we can stop here. That can be my final answer. Or I can rearrange these. But you have to be careful when you rearrange them. You have to write your x term first, but you look at the sign in front of it. This is not 2x minus 4, because the 2x here is negative, so it has to be negative here. The 4 is positive, so it would have to be plus 4 here. At this point in time, either one of these answers would be acceptable. Number 2, and I'm just going to rewrite the original equation first. They want us to solve for h. H is in my numerator on the right-hand side. That means, as I look at my equal sign, h will stay on the right-hand side. S is the only other thing with it. It's the only thing I have to move. And if I were to translate this side, I'd say h over s, or h divided by s. Since I'm dividing by s now, I'm going to do the inverse and multiply by s. Dividing by s and multiplying by s cancels. That leaves h alone, which is our end goal. But if I multiplied by s on the right, I have to multiply by s on the left. Because it's multiplication, I can write this SW equals H. I could write this as WS equals H. Either way is fine. That's something we learned a couple of chapters ago. That's our commutative property of multiplication. It doesn't matter which order I multiply in. Standard procedure would be to write it in alphabetical order, but if you wrote it as WS, that would not have points taken off at this point.